Hello.
Sir, good evening, sir.
Good evening, sir. I'm just wondering whether I'm on or not.
Yes, sir. Thank you so much, sir. You are on time. Thank you so much, sir. We'll
Okay.
start the session in just 2 minutes, sir.
Oh, I just came in somehow. For various reasons, it took me too much time to come.
Oh,
So okay, I'm ready. I'm here now.
yes,
Okay.
sir. Yes, sir. We'll just start the session, sir. So I think you had a great time in the morning session, sir, at college.
It was very good. We enjoyed it. It was all very nice. Okay. Can you hear me very well with this?
Yes, sir. We can hear you, sir. We can hear you.
Oh, okay, because I'm not quite prepared. I'm just walked in and
Okay.
so I just want to make sure
No problem.
I didn't pay
Yeah. Good
attention to
evening,
life.
all the teachers who are watching this live webinar. Today, first of all, let me convey my wishes to all the great mathematics teachers. Today is the National Mathematics Day. We are celebrating the National Mathematics Day. I think, in my personal opinion, uh, maths has to be celebrated more because as a physics teacher, I know the importance of maths. I always say that mathematics is the language of physics. So without having a sound knowledge in maths, so it is no use. So students should understand that learning mathematics is very, very important. I see a lot of time the pain in solving problems in physics comes only because of this mathematical basics. So maybe they're worrying more about the marks over the knowledge. So I think this has to change. And definitely, if the students have that knowledge of mathematics, all the fundamentals are in what called as thorough with all the fundamentals are thorough. Definitely, physics is going to be very easy for us. And I always say that a student enjoy physics more if he's good at mathematics. Otherwise, what happens is it is killing a lot of the time in solving problems. So physics requires a lot of fundamentals in maths. They should be good at algebra, calculus to some extent, and trigonometry very important. So definitely, these sessions hope that they'll understand the importance of mathematics. And in recent time, we are all talking about artificial intelligence and data science. So the lot of new jargon has come, and what exactly all they're doing. So how they need math. So we have other session with Viswanath Gangavaram. He is going to share today. So without wasting much time, let me introduce the today's speaker, the keynote speaker. You all know Patnaiks are very well. In my opinion, is the best mathematician teacher I have ever met in my 24 years of career. And we all know everybody in Vishakhapatnam, they are aware of Patnaik sir. He is such a wonderful math teacher. And beyond that, I am working in SN class from last 8 years. I never felt he's a director. He always make sure that the faculty feels comfortable and is just like a more than a friend. I know Patnaik sir from 2 decades, more than 2 decades, but I have seen him the same way even after 20 years also. That's the greatness of Patnaik sir. So we made one small a video on Patnaik sir long back. So I just want to share that, and that introduction.
You should just allow me to talk. You don't need that big introductions
No, sir.
and
No, sir. People,
videos and all
people,
that.
a
Look,
lot of
okay,
people join from other. They
I'm
are
just a
watching
good
from other
guy.
places, sir. It is our privilege, sir. It's a privilege for us to tell the world about your greatness, sir. Because very few people are the fortunate enough to work with you, study under you, and work with you. And it is one privilege, sir. So it's just a minute of video, sir. We don't take much time. So I hope you all can see the YouTube screen, right?
Yes.
Yes. Okay. Thank you, sir.
Yes, sir.
Yeah. Everyone, can you hear the sound? So it is very difficult to tell everything about Patnaik sir in a small video. So we did a small attempt. Uh, uh, Once again, I invite you, sir, for this wonderful evening. Dear teachers, let us all hear from the Patnaik sir, who is an expert in mathematics and definitely I hope you all will enjoy his speech. Sir, it is time for you, sir. You can talk.
Thank you. First of all, how much time do I have altogether for
Uh,
the lecture?
you can talk about 25 to 30 minutes, sir. Your choice.
Thank you. Thank you.
Okay.
Well, first of all, thank you for a lot of very nice words you said about me. But I'm not all that great a mathematician. I'm just a good teacher. Probably I enjoy more than good teacher. I think I enjoy teaching. I love mathematics. I enjoy it, and I love to communicate mathematics to my students. And I think that students have, people at the students that I teach, 15, 16, 17 years of age, are extremely energetic, and they can do a lot of things if only they have confidence on themselves. So, and I also see math is such a wonderful subject. It gives immense pleasure to the person who is actually studying it. It also gives you a kind of a skill or kind of a faculty by which you can understand things in a first-hand way. An equation can communicate to you about the nature of things as much as you are a part of the nature. When you feel how the nature is going around, the same kind of an experience, that's what I said, first-hand experience, you can gain through the equations. Math has an aesthetic sense and also an application sense. A lot of people do mathematics for application. I do a lot of mathematics for application, but at the same time, I do enjoy the way the mathematical structures really treat you with some wonderful goodies. So in that sense, if you look at, this is the day we celebrate as the National Mathematics Day in India, because of the great man, Srinivas Ramanujan. Srinivas Ramanujan has studied mathematics for the aesthetic sense of it. So we'll talk about what it is really in a minute. He's one of the greatest mathematicians, comparable to only the all-time greats like Gauss, Dirichlet, Legendre, Jacobi, and Euler. And even in a short span of his 32 and a half years of life, he has produced monumental work which has not lost its luster in spite of many of the modern inventions. It's all because of this man who came from a small town and apparently not so well to do. And he was very poor, especially because he was so passionate about mathematics that he has not taken care of himself. He, in spite of the fact that he had scholarships to study because of his brilliance in mathematics, he couldn't keep those scholarships because he didn't pay attention to the other subjects. Unfortunate that his direction had to go that way. Had he been able to do FA exam very well and gone to university, people would have recognized him very easily. But he's an artist. He's not bothered about anything. He's completely immersed into investigating what this beautiful number system really offers. He was not exposed to enough mathematics at that stage in the school. He didn't have an access very many great books which would have taught him more. He had only what's called course synopsis, apparently a compilation of just a lot of formulae without much explanation. And he saw some of the formulae are very enticing, very beautiful, and he knew how to generalize them and write more formulae, but not pay attention to the very thought process of the proof to be presented to the reader. So his style of writing something is that put everything in his head and somehow or other write down the formula. That was his style. At best, maybe one or two sentences in the middle. So that is how it started off. Now, it's only because he's completely immersed into it, completely constantly thinking about it, that he could really stray too far into the field of number theory. Number theory requires an enormous amount of complex function theory. I don't know who are my audience. Many of the people, I'm sure, scientists and researchers and as people who have studied complex function theory too, you understand that complex function theory is a very powerful tool and it's completely essential for the modern man to study number theory. But he doesn't have any kind of a background in that. Even G.H. Hardy says he's just completely astounded that here is a man who is able to say such deep results, yet he doesn't understand or doesn't care for even Cauchy integral formula. People in mathematics are supposed to know that, and especially number theorists. How he was able to imagine, I don't think anybody, uh, you know, uh, deciphered it. Probably nobody would. Uh, anyway, the story of number theory would start with primes. Um, if you look at the primes, they start with 2, 3, 5, 7, 11, 13, but slowly they become sparse. Indeed, if you look at the first 1,000 natural numbers, 1 to 1,000, you will have about 180 primes or so. If you look at the next 9,000 up to 10,000 natural numbers, if you really look at it, you will get another 190, 100, less than 200 more primes will be there. If you keep on going like that, if you go to, actually, the primes will slowly, they sparse out. There will be very fewer and fewer primes as you go further and further, but yet there are infinitely many primes. So Gauss, Carl Friedrich Gauss, one of the greatest of the men ever lived on this planet, at the age of almost 11 or something, was looking at the list of primes, and he was able to realize that the number of primes up to any large number x is comparable to the ratio x by log x. In other words, if you take a large number, let's say 1 trillion, and look at the number of primes till 1 trillion, the number of primes will be 1 trillion by log 1 trillion. 1 trillion is about 10 to the power of 12 or something. So that is 10 to the power of 12 is 12 log 10 into, say, about 30, right? 12 log 36. That means the probability that you can pick up a prime from 1 to x will be what? X by log x by x, that is 1 by log x. The probability that you pick up a number from 1 to x to be a prime is 1 by log x. So 1 to trillion, if you want to look at the numbers, the probability a number chosen at random is a prime is some 1 by 36 or something like that. So the probability goes up. Indeed, if you look at all the natural numbers, you want to pick up a number, and what is the probability it is a prime number? It is 0. In spite of that fact there are infinitely primes, it's 0. So the distribution of primes is what we want to see, and Gauss saw it almost at the age of 11.
So, Patnaik sir, you went on mute.
Yeah, can you hear me now?
Yes, sir.
Yes, sir. Yeah.
Okay, I'm sorry. If you look at one prime at random, one number at random in infinitely many natural numbers, I see it's going off. You can hear me now again, right? Okay. Yeah.
Yes,
If
sir.
you look at the primes 1 to all the numbers, and if you take one number at random, the probability it is a prime is 0, in spite of the fact there are infinitely many primes. So, in spite of the fact that Gauss guessed that the primes up to x is asymptotic to x by log x, he was not able to prove all his life. He lived 88 years. He tried many times. And one of his students, Rayman, just to impress his teacher, as a small lecture he's supposed to write for application of position of a tutor at University of Göttingen, has written a small article, 10-page article on prime numbers. Of course, it's not a small article. It's a very profoundly deep article. In that, he has somehow he wanted to write a proof of the prime number theorem. He came very close to it, but there is one small thing pending. That is the so-called Riemann zeta functions zeros. Riemann zeta function, I'll tell you what it is, has very trivial zeros, all negative integers, -2, -4, negative even integers, -2, -4, -6 are all natural zeros. But there are non-trivial zeros on the real part of z equal to half. So Riemann actually realized that if you can prove that all the zeros of the Riemann zeta function, he didn't name Riemann zeta function anyway. He said zeta function. Later on, we called it Riemann zeta function. Okay. Anyway, if all the zeros of the zeta function lie on real part of z equal to half, then that solves the prime number theorem. That's what he really wanted to prove, but he was unable to complete it. You know what? That was about 1820 or so. And prime number theorem was eventually solved by Hadamard and Poisson independently. It's a very 200 long page manuscript. It was a very terse calculation. Somehow they solved it at the end. But Riemann-Zeta hypothesis still sits there after about 200 years, 227 odd years. And indeed, the Clay Foundation offers a prize of $1 million to anybody who can solve that problem. Of course, solving the problem in turn also will somehow influence the technologies that we are using in these days. For example, data encryption, we use, apart from symmetric cryptography, we use, let's say RSA is quite well used, I'm sure, I think in banking, this PhonePe and other banking sectors and so on. Several places RSA is used. The solving of the Riemann-Zeta hypothesis, the ability to prove the Riemann-Zeta hypothesis would perhaps give an ability for people to factorize huge numbers and so on. That might create a nuisance to the RSA algorithm. A lot of people believe that. Anyway, that Riemann-Zeta hypothesis is not solved, let's say. Now, what is very mesmerizing is that many other people also have thought about the prime number theorem, apart from Gauss. I think Legendre also thought about it, and perhaps Euler actually did extensive work on Riemann-Zeta function in the real plane, on the real line, not in the complex plane. Many people have done wonderful work. Ramanujan also thought about prime number theorem. In one of the first letters he has written to G.H. Hardy, he has indicated a certain formula, which is all about, getting the approximation for this. He has a different approximation. He approximates the number of primes up to x with what is called Lex, which is integral 2 to x dt by log t, something like that. However, he is not presented a proof. Later on, he submitted a part of the proof, which was also not correct. That's a different story. Whether it's correct or not is a different story. Actually, correct proof is only proof. Otherwise, it's not a proof. But what I would like to say about what G.H. Hardy said about Ramanujan with regards to this, because Ramanujan, apart from this, he has produced some other results also about distribution of primes, which are far-reaching than the other people. What G.H. Hardy said is plainly clear that Ramanujan had a formula in his hand, and the other people who ever had any formula on their own are only the greats like Gauss, Legendre, Dirichlet, and people like that. And what Ramanujan did went beyond that and deeper into the subject. So he credits Ramanujan for that. But now, with regards to even understanding the Riemann-Zeta function, it is not an easy function. Of course, a lot of mathematics may not be easy, but as far as this is concerned, it requires the zeta function is not going to behave so very many places. You have to extend it analytically somehow or other. So you need to have a good command and the complex function theory to understand the analytic extension. For example, zeta minus 1, zeta z is sigma 1 by n power z. Okay, I don't want to say too much about it. 1 by 1 power z plus 1 by 2 power z plus 1 by 3 power z ad infinitum is zeta z. For example, zeta minus 1 is 1 by 1 power minus 1, which is 1, plus 1 by 2 power minus 1 is 2. So 1 plus 2 plus 3 plus ad infinitum is zeta minus 1. Okay, actually, that is infinity as it is. However, if you carefully manipulate the function, extend it analytically, you can extend it, and its value, if you want to make the function analytic up to minus 1, its value should be minus 1 by 2. What is that? 1 plus 2 plus 3, etc. ad infinitum. When it is minus 1 by 12, the function very well fits. Infinity doesn't work out. Similarly, 1 squared plus 2 squared plus 3 squared, etc., which is zeta minus 2, should be 0. That is not a meaningful thing for a layman. Okay. But if anybody understands what those extensions are, it is really amazing. What we see that Ramanujan has actually all these numbers calculated, computed. And indeed, in the first letter he sent to Professor Hill of London, asking him to support him in his mathematical inquiries, he has sent this formula. And Professor Hill misunderstood those things and said, look, this man doesn't know what divergence series are, he should probably read Bromovich's divergence series or Whittaker's complex function theory or something like that, and return the letter back. That is why he was very careful when he wrote a letter to G.H. Hardy. He did not send these details, but send somewhat even, these are deeper results already, somewhat other deeper results which were really scary. G.H. Hardy found out that some of them he could solve, and his friends, Littlewood, Wright, they were all very great mathematicians of the Cambridge College at the time. They have solved few of them, but some of them, G.H. Hardy said, that are extremely interesting and very difficult and deep, and nobody else ever thought about. Indeed, for example, Ramanujan works on partition number. I don't want to say too much about what this partition number is, even though it's easy to understand. It's a online. I'm talking. I'm not writing anything, so you should excuse me. The expression for the partition number Ramanujan gave, and subsequently with the help of GHRD and the others proved, is a result which was never thought about by any of the greats I was telling you a while ago. That's what nobody even thought about looking for a formula for the partition number. But Ramanujan did think about it and even produced a formula for that. Okay, there will be failures here and there. Maybe he didn't get the prime number theorem's proof right. That's a different story. But he had extensions of the prime number theorem, which are extremely mystical and majestic, and only Ramanujan could do that. Another man I was talking about, Euler. Euler was very extremely, prolific writer, an extraordinary scientist from, I think, Switzerland, and Leonard Euler. And he was apparently so very good at calculating, calculating numericals and numbers. So very good that people say that like men can breathe or eagles can fly or sustain in the flight, Euler could actually calculate. You see that? Like men breathe or eagles sustain themselves effortlessly in flight, Euler could calculate. So you can imagine how wonderful it is that if you can calculate like that. I'll tell you the kind of calculations he has done, just absolutely incredible. A very simple calculation I can even teach to just a 2-year intermediate student, but not easy for him also to compute it because numbers become too very big, equations become too long, too involved. And at the end of the whole story, he should be able to compute something like zeta minus 2, zeta 2. Zeta 2 is 1 by 1 squared plus 1 by 2 squared plus 1 by 3 squared. He computed zeta 2, zeta 4, zeta 6, all the way up to zeta 26. By the way, I should tell you, Leonard Euler, for some reason, has gone blind almost at the age of 36 or 37. It is a blind man who can't see anything. Okay, without the help of his grandchildren, he cannot walk. This man computing 1 by 1 power 26, 1 by 2 power 26, 1 by 3 power 26 ad infinitum to be equal to, I remember I have the number right in front of me, huge number, 1, 3, 1, 5, pi power 6 pi, 1, 1. I don't no need for me to read that. I have about 20 digits in the denominator. Okay. And this man he was blind, was able to calculate such kind of numbers. French Academy of Sciences wanted to publish all the works of the Leonard Euler, and they have given out a lot of funding to publish, and they have published about 70 huge volumes, and still there is so much more work to be published. They said, okay, this is good enough for the present. We will fund you later. I don't know really real story, but they have published about 70 volumes of huge monumental volumes of work by Leonard Euler. He is a man who became blind at the age of 35, 36, right? These are the people with whom, Hardy compared Professor Ramanujan. Only unfortunate thing about Ramanujan is that he didn't go through the formal education properly. And he, at the right time of his life, he should have gone to the right universities to actually know how to present a solution. he didn't know how to present the solution. In mathematics, what happens is a mere formula is not enough. You need a proof of the formula. Proof of the formula is a lot more important than the formula itself. Anything you write up as a formula or a theorem or a conjecture will stay there as a conjecture for a long time, like Riemann-Zeta hypothesis. You need a proof. In that sense, um, I think his journey to Cambridge and subsequent, collaboration with great men over there has given an opportunity to write out a lot of things. But when he came back from Cambridge back to India, and he was kind of sick, and he was very sick. He didn't take care of himself. In the last 1 year, he was in a rush to write something. He was in a rush to invent many, many things. He has introduced only recently what are called Mach theta functions, and he wrote enormous amount of work. Everything is compiled to nearly about I can't remember some 130 pages or so of work. And after passing away, his wife has delivered it to the University of Madras, and they themselves, excuse me, they have uh, sent that manuscript to Cambridge. I think that was a war time, and people didn't pay much attention. G.H. Hardy was also busy with other things, so manuscript was lying there for some time. Later, he gave to Watson to actually look after that, and Watson was having that manuscript with him for some time. They were actually loose set of papers punched up together, not really a bound book. Watson was old, and subsequently he asked somebody else to do it, and he passed away. And the whole document was sitting somewhere in the dustbins in Ren Library. They were not dustbins; they were all preserved, but nobody bothered about what all these papers is. They're not sorted out. And somehow, fortunately, Professor Andrews from Urbana-Champaign, perhaps I don't remember, was on sabbatical at Cambridge, and he went through the pages, and he went through the library, and he was able to spot this small bunch of papers involving the writing of the Ramanujan. You know what? When they found it, they have found that there are actually on the lines Ramanujan has talked about Mach theta function. Many people have already did a lot of work on Mach theta functions over the past maybe 100 years, some 60, 70 years. But after this work of Ramanujan came out, most of the results, most of those results have become obsolete. That Ramanujan's work has superseded everything. However, there are many, many formulae which he has not presented the proofs of in that. And so they're all sitting there as things to be proven. So a lot of unproven results Ramanujan has produced, but people know. But when Ramanujan wrote something, he has wrote with a proof in his mind, but he is not presented it. So in that sense, uh, Ramanujan's legacy sits there for a quite a long time. It takes several years, perhaps, before all these things can be proven. Now, as far as the Ramanujan's motive towards doing this is the fun of understanding the numbers, the pleasure he has derived in playing with the numbers, and the kind of a deep insight he has, and the ability to handle uh, very very sensitive and sophisticated relationships between various different areas of the number system. Actually, this fun which he had is what drove him to study number theory. He also believed that and this is such an important investigation that he's doing, and yes, it is, because number theory is very, very surprising. There are a lot of very simple questions anybody can ask in number theory. For example, uh, Goldbach conjecture is a very simple conjecture. It says that if you take any even number greater than equal to 4, every even number greater than equal to 4 can be written as sum of two primes. For example, 6 is 3 plus 3, 8 is 5 plus 3, 10 is 5 plus 5, okay, 12 is 7 plus 5, 14 is 7 plus 7. Every even number, you go keep on trying it. And people have tried up to 10 to the power of 10 to the power of 10 or something. Every even number uh, seem to be sum of two primes. You have to prove. Unfortunately, there is no proof for Goldbach conjecture that the people knew about 350 years ago. Even now, that result is not proven. Why, for example, twin primes which come successively, for example, 3 and 5. Of course, 3, 4, 5. 4 anyway is not prime. So 3, 5 are the consecutive primes, we want to say. 3, 5, 5, 7. But 7 and 11 are not consecutive prime. Between 7 and 11, you have another odd number 9, which is not a prime. So twin primes, whether there are infinitely many twin primes, that is one of the problems. Actually, people, that is a open problem, and we don't have a solution for that. I can tell you many problems people can easily understand. They actually say that any fool can give a problem in number theory very easily, but even the wisest of the men will find it hard even to visualize what a proof could be for such a problem. That's the mysterious nature of the number theory, unlike some other fields. Number theory is also, in a sense, a very romantic subject. You just will become so fond of numbers. You're immersed in that beauty of wonderful things. Like, for example, 1729, for which Ramanujan said it is a sum of two cubes that can be written in two different ways. 1 cube plus 12 cube equal to 9 cube plus 10 cube. Okay. There are a whole lot of other, other identities you can figure out, which are like sum of powers of five powers of force, sum of fourth powers of 5 terms become the fourth power of another. Such things are very mesmerizing, and it's not easy to get. And Ramanujan certainly has a whole lot of things. Even have given you infinitely many solutions for such things, parametric solutions. That means if you plug in a parameter here and a parameter there, you actually get a whole family of solutions. He gave families of solutions for them. He wrote in his notebook for several such identities. So it looks very romantic to play with the numbers. That's what number theory is all about. And even I remember while I was studying MSc, I was doing a course in number theory. I was also like, I'm dreaming about numbers all the time. For whatever reason, I have chosen a different direction, and I'm very fond of the direction that I am working in. And, but I don't know any number theory at all now. It's a very limited number theory, I know. In that sense, I'm not really a competent man to talk about such a great man like Srinivas Ramanujan, except that I love a man like him, and little that I know, I wanted to communicate to you. Sir, how much time you said I have? Another 5 minutes I have or something?
Yeah, Patna sir, you can carry on, so no problem.
Okay, very good, very good. Okay. So another thing is this. Let's see. In terms of applications, these days many fields in mathematics are developed on the basis of applications. I told you right in the beginning, we do mathematics for two purposes. One is the aesthetic sense, the sheer pleasure of doing it. Other is the application sense. Um, but the applications don't come so very quickly. Sometimes when we invent something, it may take another 500 years before its use comes to the world. And it's not so easy. For example, maybe it's a funny thing I read somewhere. Apparently, one of the kings around there came to Faraday's magic show. Faraday used to put a lot of magic shows with electromagnetism, and he was there, and he was very mesmerized. They were very happy looking at the magic show put up by Faraday, and Faraday requested the king to actually give a grant to pursue that science a little further. He said, for the magic, what is the need of a funding, really? Electricity is some magic thing, he said. You see, people don't understand that. So at that time, he thought that what's the big use of this electricity that we invented? That was in the beginning of that. I think all of you understand uh, how silly it is now. Okay. In that sense, we mathematicians don't care much about how it is going to be used, unless we are actually solving directly a problem which is of practical nature. Now, two things I'll tell you. For example, Everset Galva has done an enormous amount of work on what is called Galva theory. You have probably hundreds of books, okay, thousands of papers. If you go to a library, you'll have a whole lot of literature and enormous amount of literature on Galva theory, right? But the entire symmetric cryptography that runs over here will depend only on the first few pages of an elementary textbook in Galva theory. The trillion dollar data security and encryption standards that they go around, I'm not quite aware of how much is the money that goes into that all, but all that is dependent on the first few pages of the elementary Galva theory. And you have thousands and thousands of papers and works written down and many books written down, huge bulky books. If you're a graduate student, you have to prepare for an exam. You don't do all the Galva theory, you just do a little bit of it. Just such big bulky books, only when you are an expert into that you read. In spite of the fact that there are so many books, I promise you, the symmetric cryptography, AES, DES, and other things will depend only on the first few pages of the Galva theory. That is the kind of application available to us. That is the kind of far-reaching applications, very elementary results in mathematics really give in every area. But mostly many of the mathematicians are driven by something in the back of their mind of solving a problem. For example, when Riemann was trying to solve the prime number theorem, I'll tell you this, Riemann unfortunately also died very young, almost at the age of 35, 36, he died. And his house is, I think, very close to the University of Göttingen. And one fine day, somebody saw some fire, some smoke coming from the abandoned house of Riemann. So they ran coming to see what happened. The maid over there thought all these papers are useless and she wanted to burn some of them. Some of the papers were burned, but these people stopped here. And amongst those papers, they found the paper in which that's not burned, in which they found where Riemann was actually trying to figure out why the prime number theorem was working, and was looking at the Riemann zeta function. That paper, on one side, is the study of the Riemann zeta function for its proof in prime number theorem. On the other side is the study of the stability of the rotating drops. The study of the rotating drops somehow also is deeply connected. The stability of the rotating drops is deeply connected to the Riemann zeta function. So he's working out the same thing on both sides simultaneously at the same time. Many of the results in mathematics, they may look to be abstract, but behind that abstractness lies a very fruitful, quite useful, deep insights into the field that it is relevant to. Other things I really love about mathematics is sometimes equations are just you write one line equation. Okay. You can say it's a quasi-elliptic equation. That's all. You don't even have to write anything. The minute you say quasi-elliptic equation, already mathematician knows what kind of a system it is, how the system behaves. You already know a whole lot about that system. And when somebody asks a physical problem about that system, this equation comes and tells you many things you want about it. Just one equation. You don't have to write a whole book about that. That means the essence of the nature of the reality is packed so very nicely in one equation. Of course, you have to study the entire theory of mathematics and understand the language of mathematics, go through rigorous training. If you say in Telugu, tapassu, okay, you do penance. Then at the end of the whole thing, you understand the language of mathematics, and that equation can reveal that first-hand knowledge about the physical world, the nature of the physical world. This particular equation is describing. Otherwise, this equation is a straight equation. You don't get nothing out of it. It's just like a simple sentence rigmarole. Nobody understands. But for mathematicians, it reveals a lot. Just the word quasi-elliptic equation already says something in your mind. It's a harmonic function. It says a lot in your mind. It's an analytic function. The minute somebody says it's an analytic function, already something is happening in my mind. Are you following me? So it is, mathematics is in some sense compactifies lot of wisdom into simple lines, which can evoke so much emotion into you. Just the simple equation can evoke so much, emotion into you. What can it do? The people who love God, they pray God, they're so much engrossed in thinking about the God, are thrilled by it, right? When you see the idol, you're so thrilled by it. Okay. And mathematicians are thrilled by these uh, equations. They're the gods for them, right? And that is the reason being they reveal the truth of the nature in a very compact, extremely compact form. And here is a man, Ramanujan, in spite of very scanty resources, a poor background he has, in spite of all that, he has completely dedicated himself to the pursuit of the numbers, and he have achieved such pinnacles that very few people in this world, on this planet, could have achieved it. And we are actually very proud that this great man has come from our country, India. And he is also an example for our young people to recognize the capacity that they have, the achievements they can do, if only they focus on the subject matter at hand. So let us remember Srinivas Ramanujan, who will be there in our lives forever. Thank you very much.
That's wonderful, Patnaik sir. That shows how well read you are. One important thing that I learned today is any even number is a sum of two prime number. So that I never knew, sir. Thank you so much for telling that wonderful fact. And definitely, sir. When I was working in Sri Chaitanya, I had an argument with one of the maths teacher, KJR sir. And I used to say that, sir, physics is far better than maths. Why people want to learn maths? Because physics has a lot of applications. I was just, amateur. I was arguing with him. He said one thing, sir, that struck my mind. Venkatesh, see, mathematics gave you a scope to think. This is the one subject that teaches you how to think. Okay, if you know how to think, you can do everything. So that one thing, then I understand the importance of mathematics in everybody's life. So thank you, sir, for sharing your valuable information with us. And we request you to, if you can stay for another half an hour,
I'll be,
it will be great, sir.
I'll be,
Thank you,
I'll
sir.
be here.
Thank you so much.
Thank you.
Yes. So now, without wasting much time, let me introduce the today's another speaker, the young man. We want to learn how this mathematics really helps us in real world, because now everybody is talking about the data science, artificial intelligence. Are they same? Are they different? We don't know. So let us all understand from this young data scientist that we have on today's session. So let me take the privilege to introduce Ms. Viswanath Gangavaram. He did his MTech from IIIT Bangalore, conducted research at IIT Bombay and even HP Research Labs. First generation of data scientist with 14 years of industry experience, and he has 2 patents and 2 research papers and more than 10 plus technical blogs. That's wonderful. And he is working currently as a senior principal machine learning scientist, leading RECO, ads, and GenAI ML charter at NICA. So, Vishnu Gangoram, thank you for joining all the way from Bangalore. And he's going to share how mathematics helps in artificial intelligence. So, Vishwanath, now your time starts. I'll make you the host. You can go ahead.
Yeah, I mean, I felt like I took a risk of talking after immediately after the Patnaik sir, after such an he enthralled us for the last 30 minutes or so, not only with the beautiful mathematical equations, but with a beautiful poetic language. I mean, use the words like romantic, fun, pleasure, entice, aesthetic. So I'm little scared whether what job I can do after this. But I'll give it. Given that I agree to speak, I'll give it. I'll give it a try.
Yeah, now you are the host, Mr. Islam.
Yes. Yeah. Seems like, can you maybe can you yourself present the screen? I mean, I already gave a this thing. I'll just keep moving the slides. I'm not sure
Okay.
whether I think I'm facing some problem. Not sure if I can. I need to set
Can
up
you
some.
share your PPT with me?
I did it. I at least shared in the chat itself.
Oh.
Can you able to share it?
So let me. I need to be the host again.
Okay.
Yeah. Can you share the screen?
Not yes. Yeah. Can you click on the slideshow? Top right. Top right.
Top right. Yeah.
Okay, good evening. Good evening, everyone. Thank you, Venkatesh sir, for having me here, especially, I mean, with August presence of Patnaik sir. My talk is about, I mean, as Patnaik sir said, right? We get attracted to the mathematics. I mean, for two specific reasons. One is aesthetic. The other one is applications of mathematics, obviously for improving our life, right? Which is typically the business, right? So my presentation is about how to use the mathematical equation to improve business efficiency and effectiveness. So it's like as Venkatesh was saying that I'm practicing data science for the last 14 years. So I'll just give a bird's eye view into the practice of data science from the industry perspective. Yeah, next slide. Next slide, please. Yeah, cool. So, I mean, definitely, as Sir was saying that, right? So, when data science is a buzzword, and we are hearing about this buzzwords in out paper everywhere, right? In research paper and research journals and in out paper everywhere, we hear this terms data science, right? So, and in general, the data science is an umbrella term for many of. So, more than data science, right, some of you might have been heard the following phrases like data analysis, data mining, statistical learning, AI, machine learning, deep learning, blah blah blah, right? So these are all these phrases typically. I mean, data science is an umbrella term for the applications of these particular fields, right? And you name it, any other term, any other subject that comes to your mind, more very likely that there's some probability that that field itself is an application of data science. Next slide. Example, I mean, you know that, right? So I mean, Jeffrey Hinton won the Nobel Prize in physics in 2024, right? And got for, I mean, he was doing data science. He was doing data science using artificial neural network for to model the human intuition. That's how he phrased it in his Nobel banquet speech. So he actually is a practicing data scientist from last 40 years, and God forbid he got Nobel Prize in physics because he uses at least the Nobel Committee thinks that he uses statistical physics to create Boltzmann mission, which is basically models the characteristics elements of it models some characteristics of data, right? Which is the definition of the data science. Next slide. So yeah, why there's so much fuss about it? Next slide. Because AI is a new electricity. When I mean, it's like a joke, right? It was Patnaik was saying that, right? So Faraday, I mean, the king at the time of the Faraday, the joke when he didn't understand electricity. So, and we know the importance of electricity. And then the same is the case around 30 years back. AI is, someone might have thought of, it's basically maybe in hindsight now we can say that it is electric. I mean, it's like AI is as, I mean, it's like a, what does it mean? It's basically electricity is pervasive everywhere. I mean, even to have this call today, we need electricity right to attend this session. So A is going to be that pervasive. That's what is the new electricity, the phrase means. Next slide. Yeah, so another way to look at it, I mean, I just came across this book around a year back, the data-driven science and engineering. If you look at it, right, so some of there are some phenomena. I mean, it's becoming so pervasive. Why? So as Sir was saying, the analytical methods, derivation based on the first principle. There are some problems which are not amenable to the from the first principles of data, the first principles of those fields, right? So even there, the data driven approaches pitch in and then solve a diverse range of problems in the field of turbulence and modeling the brain, made brain processes, climate, and epidemiology, and so on and so forth, right? So these systems are typically non-linear in nature, dynamic in nature, and then high dimensional in nature. Next slide. Okay, so the next 10, 15 minutes, I'm going to actually define the data science and then on how typically say as a data scientist, my job is to take a business problem and then map it into data science problem. That's a personal journey, and that's what I'm doing it for the last 10, 15 years. Next slide. So if we can basically, in a very crude term, in a crude, the definition of data science is basically it's a study of data to extract meaningful insights for the business sake, at least in the industry setup. So it's a another way to look at it. It's a multidisciplinary fields that combines principles and practice from the field of mathematics, probability and statistics, AI, and computer engineering. And as I say, right, as we saw in the first, right, the definition is analysis of the data to extract meaningful insights. So basically, while we're analyzing the data, we ask a bunch of questions. We ask following questions, right? What really happened? Why it happened? What will happen? So on and so forth, right? So by asking these questions, we derive some insight, and we use those insights to improve the business. That's the idea. Next slide. Okay. So why business is I mean, business is interested in to increase their bottom line, right? So that's why the industry is interested in data science. Next slide. So typically the bottom line, next slide. For the business, the bottom line is the bottom line being the profit. Profit comes from the two ways: by increasing your revenue and by decreasing your operational costs. That's how business makes the get the profit. Next slide. So okay, how because most of my career is into the e-commerce business. Like I was in Swiggy for 5-6 years, and then Nika in the most recent last 1 year. So most of my life is in the e-commerce space. It's okay. Whatever the next 10 minutes, I'm going to go move from an e-commerce perspective, specifically from Swiggy example, because that's where I spend most of my time. So as I said, right, the business use the data science to increase their bottom line, increase the revenue, decrease the operational cost, right? So how e-commerce business increase the revenue? Basically by reducing the friction while a user is using their apps, right? So by personalizing the content. So based on how they, so example being Edgroom, I mean, let's say in Facebook, right, or maybe the Instagram. So basically the feed that they show us is basically very the feed that we love it, because they basically log the interactions that we do with on the platform of over the last few years. And the next content that they show to us is the content that we most likely to convert, most likely to click, most likely to view. So these are the signals that we leave on these are the traces that we leave on those platforms. And then they use our signals, and our interests and preferences, and optimize and then and personalize our feed so that we do more of click and etc. Next slide. Example being the first screen that you see on Swiggy app, that you most likely what's in your mind and your trusted picks. So basically they use the logs, the interaction logs that we left on the platform. Next slide. I mean, I think I was just saying that they use our interaction logs, that our interaction logs are clicks and etc. etc. Accordingly, they use the mathematical data science model. So what basically the data science model uses, basically it use our personalized signals and then optimize for propensity to click, propensity to convert, so on and so forth. Next slide. And yeah, saying that data science and a machine learning model is just a function. Next slide. And as you know, okay, next slide. And as you know, function is just it captures the relations between the variables, independent variable, dependent variable, in this like x1, x2, or the features, right? Features / independent variable, and why we call as a dependent variable. And you see there are different and the relationship between independent variable, dependent variable is what we call as a function. And then if you see the first two functions are linear function, and then whereas the third function is an exponential function. So they have a function form, but a functional form is what captures the complexity of the phenomena between the relationship between the variables. But nonetheless, at the heart of it, it's just a function with the independent variable and the dependent variable. Next slide. I mean, most of us, I mean, one of the simplest thing that we might have learned in one of the simplest machine learning model is a statistical model, is basically the linear regression, which is try to, in a linear regression, the assumption is the relationship between an independent variable and the dependent variable is a linear function, right? So as you see that the line, the dotted line, right? That's what we call as a best fit line. That's what we call the best fit line, right? And then all those the white dots that you see, that these are the observations, and then these are the example. Right? Let's take an example. Let's say like a example being, let's say the y-axis is the price of the house, and whereas the x-axis can be, all these x's can be the number of rooms in a room, number of rooms in that building, and then the location. So these are all the independent variable. All this multivariate linear function, the form of whatever the linear function, right? Which actually with that function form gives, once you compute that function, you get the price of the house. Example is in that rudimentary form. Next slide. So basically, as I said, right, linear regression is one of the simplest machine learning model. And just if you look at it, what the machine learning / statistical learning model, which is basically, if you look at it, right, what was given to us, those white dots, the price, given the x's, we have the corresponding y. Okay, so that's a data. So we were given the data to us. We don't know which, and there is a phenomena. There is some phenomena. In physics, we model the natural phenomena. In business, we models the users, we models the user behavior, right? Sorry, that's a simple thing. We don't model the natural phenomena. We models the business interactions. That's the difference. So if you look at it, right, so we were given the data. Now the job is to identify. Now the job is to identify those betas. These are called model parameters. And typically, such a model is known as a parametric model. Also, it's basically it's a parameterized by betas. That's the heart of it, right? But the job is basically for a given beta naught and beta 1. And if you see that, right, that is your model. That's your model, that red line, right? And so if you look at the gap, so for a given xi, you see that, right? The model gives some yi, and then then if you see the gap between the blue dot and the line is known as error. It's basically known as error. So the model with the least amount of error is the best fit model. That's the main idea. Next slide. Next slide. If you look at it, right, so we started the one equation, which is basically a linear equation, which is a function of the y and x's, right? And now from that, so for a given beta naught and beta 1, we can actually compute something called the cost function. The cost incurred by using this model to model the data that we have with us. Okay, so that basically we call this, I think most of us might know in a least square approach, right? It's called mean squared error, which is the cost function, which is nothing but the sum, which is the sum of all the errors. Because if I use this particular model for a given beta 1 and the beta 0, this is a cost that model is going to incur. Okay, so that's a mean squared error is the cost function we call. Okay, so and if you look at it, right, so and moreover, if you look at the nature of that mean squared error, it is basically, it's a convex function. That's a given convex function. So for a given beta 1 and beta 1, and this is how the cost function will look like. That's the parabola, right? As you know, it's a convex function. And if you look at it, right, the optimal value, which is the bottom of the parabola, which is for a given b0, for a given at that b1 b0, our cost function has the least cost. Okay, the good property of the good thing about the convex functions, right? The good thing of the convex function, wherever you start, if you move against the gradient. So let's say you randomly choose some beta 0 and beta 1. You start with some initial value of the cost value. And because it's a convex function, if you make steps against the gradient, then eventually we lead to a point which is called optimal value. Okay, next slide. So this is the foundational idea that used by Mr. Jeffrey Hinton, around 1964, for the artificial neural networks. That's a so-called the deep learning models, right? But we can approach the same ideas of the gradient descent. It's called a gradient descent as a thing, right? It's a convex function. You make the progress such a way that you move the beta zero, the b0 b1 against the gradient. So so we start with right. It's a cost function. Let's say j is a cost function, which is nothing but the yi is actual value, and whereas a b0 plus b1 into xi is the predicted value according to a model. So as you know, right? So to identify the optimal parameter, we go ahead and then we can take a partial derivative with respect to b0 and b1, and then equate to 0, you get the optimal values, right? That's a calculus 101, right? So it's just a multivariate calculus at practice. The thing is, right? So whereas a gradient descent is an iterative approach. If you go to next line, this is basically for the same linear regression. We have an analytical solution, which is basically give us as a closed form solution, which is we don't use this iterative approach. It's just equating to just do the partial derivative with respect to theta, which is in the case b0 beta b1, right? Equating it to 0, you get a nice closed form solution, which is we generally known as a normal equation. Next slide. Okay. I mean, I've just started with I told you, right? This basically we reduce the friction by showing up personalized experiences, and then we have these ML models and statistical learning models to build those personalization models. So that's it. So ML model is nothing but it's just a function of the user's features, the user's interest, and then which the Y in this case is a propensity to click, propensity to convert. Next slide. So we just with the same ML, we fit different ML models. The next screen is basically rank ordering the items on the menu. Next slide. Next slide. Yeah, next slide. Yeah, we'll skip it. Okay, so we talked about increasing the revenue by modeling by giving personalized experiences. Thereby increase the revenue so that user click it, user convert, right? So there is another piece to puzzle that we can also increase the revenue. We can also increase the bottom line for the company by reducing the operational cost. Example, some of the ways that we can do is basically if you're able to accurately forecast what is the potential demand in I'm just taking an example in Visakhapatnam. I don't know. Yeah, in MVP colony, MVP sector 5. Okay, so what is the expected demand for the next 2 hours in for the next 2 hours in MVP fifth sector? Accordingly, the companies like Instamart and Zepto and Blinkit, a day before, accordingly, based on the predicted expected demand, they're going to put the necessary inventory at each item level in the warehouse, right? So if you over predict, then if we do over prediction, which is basically only 15 products are required, but if the model predicted 30, then there is a problem face stage. If you under predict, then there is an impact on user experiences because user wanted, but the items are already gone, right? So basically, there is a lot of operation that the operational cost can be reduced by having by looking at by predicting the future demand and accordingly adjust the supply and demand. Next slide. Okay, I mean, skip next slide. Okay. So we studied about data science as a study of it's a study of data to extract meaningful things, and and that's broadly and we talked about bunch of bunch of business problems where data science will be used. Next slide. And as was said, right? So data science is a multidisciplinary field with influence from the mathematics, probability and statistics, and programming and so on and so forth. Especially, there are 3-4 fields, mathematical fields, which are super has a foundations in ML in machine learning. The optimization is, and as you saw, right? I mean, as you saw those gradient descent and normal equations, etc. Optimization is everything that in machine learning is an optimization. It's an optimization application. Okay, and there is a bunch of linear programming that we use in the business. I mean, there's a bunch of cases in my industrial career. I use the linear programming and solve bunch of. I mean, to send a push notification, like you might be seeing that that you might be receiving this push notification from different mobile apps, right? So because we use a linear programming to decide on how many push notifications send and what exact push notifications send. So we use linear programming to decide how many push notifications sent. Okay, and then there is this, we use a bunch of function approximation methods like the Taylor series. There is an ML algorithm called gradient boosting mission, which is 80% of the traditional machine learning problem were actually solved through the gradient boosting mission, which is just an application of Taylor series. Okay, and information theory is at the heart of the field. Next slide. Okay, and probability basically machine learning is just a is an the new sexy term for the statistical learning. As simple as it. It's just a fancy way to it's a fancy way of saying that statistical learning. The only difference is basically in statistics. It typically you have an hypothesis that this phenomena is modeled through normally the normal distribution or a Poisson distribution, so on and so forth. Whereas in machine learning model, we don't hypothesize that it follows some particular distribution, right? We basically say that, hey, maybe this is a linear parametric model, non-linear parametric model. So which basically say that it's still some hypothesis, which is a linear function, non-linear function, or an exponential function, but we don't put up like this normal distribution, this just the Poisson or a Gaussian or something like that, right? We don't have we don't start with those hypotheses. That's a fundamental difference. Okay, so and basically typically in ML modeling is all about modeling the random phenomena, and statistics gives us a framework to the statistics give the framework of random variable, right? In life, everything is random, okay, with certain probabilities, right? So statistics give us a framework to think about this random variable, and life is all about random. So right, so give the random variable statistics give that framework, and then ML modeling is all about modeling. ML modeling, machine learning modeling, statistical learning is all about modeling the expectation of a random variable. Is as simple as that. Okay, so take it next slide. And yeah, so I mean, data science is an application of AL, artificial intelligence. Typically, if you look at it, right, maybe if you look at the Venn diagram, right, the artificial intelligence is basically it's an umbrella term wherein we encode intelligence in the mission, right? Yeah, typically there are so you encode the intelligence. You encode the intelligence typically. You encode the intelligence typically through the two ways. Can you please go on mute, please?
Ma'am, somebody can unmute yourself, please.
Yeah.
Mute yourself.
Yeah. So basically, the AI, right, artificial intelligence, the encoding of intelligence into the mission is broadly broken into two pieces. One is a rule-based system where we manually encode the rules that okay, if XYZ happen, then if XYZ happen, do something else, right? So we manually encode the rules. Whereas in the field of machine learning, which is basically we give the data. As you saw in a linear regression example, right? We throw the data at the mission. We ask us, boss, just go ahead and then learn just go and capture the intelligence by yourself. I mean, if you look at it, right, all this, any living thing like the humans, right? Basically, we get exposed to various examples in life, and then we learn what works and what doesn't work, right? Machine learning is in a way is that. Okay, machine itself is going by looking at some examples, it learns the knowledge. That's at the heart of it. Okay, next slide. Yeah, I think I'll skip it. Of course, it's a computing thing, right? Yeah, cool. Next slide. I keep it. So basically, yeah, just keep next one slide back. Slide back. Back. Just go back. Can you just go back? Please go back. Can you go back, please? Yeah. Just go to 5 slides back. Yeah, start from, yeah, cool. So I said, right, it's data science is all about study. It's a study of data to extract meaningful insights, right? And I was saying that, so we ask these questions like what happened, why it happened, what will happen. So by asking these questions, we'll get some insight, thereby we improve the business. Go, next slide. I'll just we'll actually what happened, right? And that's where we use something called descriptive statistics. I mean, we look at the mean and medians and standard deviations and correlations and etc. This is typically the descriptive statistics gives us the tools of descriptive statistics gives us what happened. Yeah, next question, next slide. Yeah, I mean, skip next slide. Yeah. So as I said, right. So as we're saying, I was talking about the personalization of the experiences in the Swiggy app, right? So basically, by doing some descriptive analysis, we understand that okay, what are the factors that influence the user's purchase decision, user's click decision, right? We understand those dependent. We understand those independent variable that are actually influencing the dependent variable of click and conversions and so forth, right? So we model the propensity to convert given the user preferences. That's the heart of it, right? So that's yeah, thanks. Slideshow. Yeah, so we started the what happened. Now if we're seeing the LinkedIn, can you go back to the slide?
Just a minute, just a minute. Yeah, can you see the screen?
Yes, yeah, slideshow.
Shall I go to the next one?
Yeah, slideshow. No, this is fine. Go to slideshow.
Okay.
Go to the next slide. Next one. So basically, by asking this what happened kind of questions, right, from with the descriptive statistic tools, we understand what are the possible independent variables that are going to influence a dependent variable, and then we also play with the multiple function forms. We call them ML models, like a support vector missions, gradient boosting missions. There are different random forest. There's a bunch of ML models that we use it both in a parametric form and non-parametric form that models the dependency between the purchase and the user preferences, right? So yeah, next slide. So this for the what happened. Now, basically, some of the questions that we ask is what will happen. So typically, there are two different ways that something happens, right? What will happen if I do something? Okay, what will happen in any way, right? These are different possible what will happen questions that we can ask. Next slide. As you saw previously, that while I was giving an example of reduction of the operational cost. So what going okay, well, this is basically what will happen if I do this. So if you look at it, right, this is a typically what we call is a randomized control trial. That basically what happen if I take a dolo, okay, will my cold will come down, will my fever come down, right? So basically we call is a that's I mean people all these healthcare industries basically they come up with a they come with a new treatments and they conduct some randomized control trial. Basically what they're doing basically what will happen if I give this treatment, right? So this is basic in examples like a Swiggy and the Nika, we ask these questions like what will happen if I give this discount? What will happen if I give this coupon? Will they convert? Don't convert? If they can, if the propensity to convert is more with a discount, then these are the people that I can give the discount. If there is if some people convert with independent of because they love that particular product so much, and they convert independent of they can convert independent of the discount, right? So basically here we ask what will happen if I do this, if I give discount, if I take a dolo. So these are called causal questions, right? So and typically if you look at the tau the one that you see in the left side, right, the equation tau is nothing expectation, you saw it, right? Machine learning is all about modeling the expectation of a random variable. So outcome in this case the purchase journey, the purchase decision, right, it's a random variable, right? So expectation of outcome given treatment is equal to S, given the subject independent variable covariates, and minus expectation of outcome given no treatment. These are called uplift modeling, which is basically and if you look at the bottom the left bottom, right, the particular this is basically the green line. The green line which is actually models which we actually quantify the how good this model is. Basically it's called area under the uplift curve. Next slide. But if you want to know more about it, I already shared my slides. You can read my technical blog there. Okay. So another what will happen question is basically previously we're talking about what will happen if I do this intervention. There's another form of question is basically what will happen. What is an expected demand? What is an expected demand? What is a number? What is the expected number of orders for a given grocery item in MVP fifth in fifth sector, right? And what is the number of orders in this particular warehouses? So these are the bunch of questions basically helps us optimize our operations, thereby get a lot of efficiency out of it, right? So and these sort of problems are known. These sort of problems is typically modeled through. These are known as the time series forecasting models. So we use this. We use models like ARIMA, which is we use models like ARIMA and exponential ETS and so on and so forth. There are some ML techniques which models these particular stuff. Okay, and if you want to know more further on it, I have a technical blog in Swiggy that I publish. Feel free to go. Yeah. Next slide. Next slide. Okay, I said right. We talked about so by asking those couple of those what happened, what will happen, so on and so forth, right? And basically, we understand we understand the where possibilities to do optimization, and then we just go and optimize our business and increase the bottom line for the company. But at the heart of it, we are an industry to increase the bottom line, and we use the machine learning to do that. Thank you so much.
That's what a wonderful listener. Because I know that data is the new oil. Now the industry is working with the data. So those people who are good at processing the data, they can get the best jobs. So from this, we all should understand the importance of mathematics. I think from my knowledge, what I understand is to become a data scientist, one be good at statistics and probability. Vishwanath, am I right?
Yeah,
Or
yeah.
can you add something to it?
And calculation.
Yes, calculation. Because all the math teachers are watching, so now we understand the real world application of mathematics. Now the world is run by the data science. So definitely, if a student really want to become a data scientist, because unfortunately, most of students they doesn't know what is machine learning, data science is all about. They're just choosing the computer science with a specialization. And after knowing that it requires a lot of mathematics, then they are thinking that they didn't learn much in school. So as Patnaik sir always says, so if you learn the intermediate mathematics perfectly, that's more than enough. You need not even you need not get into IIT also. Learn that 11th and 12th mathematics perfectly. So definitely because the probability, statistics, everything is there in 11th and 12th itself. If you can master those skills, definitely it is going to help a lot in the coming days. I just want to take 1 minute of your time, sir, Patnaik sir. Then we'll have some questions from the users. We'll wind up another 5 minutes or 10 minutes. Is it okay, sir?
Okay, please go ahead.
Yes, sir. Thank you so much. Yeah. So what exactly we are also wanted to do the same thing, sir, as Vishwanath said. A data science is going to rule the world, and we also wanted to do such a small ML and this in Edgroom because there is a lot of data is available everywhere across the internet. But how to get the required data, how to get the required information, that's a question now. So we just wanted to use a little bit of it, and maybe we are in the process of developing a full-fledged platform for the students to use. So I just take 1 minute time, dear teachers. Edgroom is started, and I'm happy to say that it was inaugurated with Patnaik sir itself in 2021, and in 2023 actually we launched this a new app called Edgroom, which is a completely a networking website where three people are there. One is student, teacher, and parent. It is a network of teachers, students, and parents. So why we want to bring these people into one platform? Because there is no single platform where you can see all the people. Instagram is meant for students. Some of the parents use Facebook, but students don't use Facebook. So we wanted to have a platform exclusive for this. And there is no one single platform for teachers. So we just wanted to have, and here you can just see a lot of teachers are using. As of now, Edgroom got around 52,000 registered users, and we are so happy to say that. And a lot of content is shared. These are all the people. I just kept maths. A lot of maths teachers have joined in this platform. They're all using it. They're sharing content. Now we wanted to bring a network of teachers across India so that we can help each other. Edgroom is not going to share any content. All the content is shared by the users itself. A lot of information is shared by the users. For example, Ravi Kumar, he shared one article from LinkedIn somewhere. So like that, all this information is published in this website. It is user-created information. And to help the student community, we can see on the right side, we created 6 products. One is called EdNews, EdBlog, EdPredictors, EdForum, and webinars and resources. I just wanted to tell you about this EdNews. This is a place where you see a curated content for the students who are preparing. For example, you see just all this information is, scraped from a lot of websites across the world, but this information is placed in such a way that students can easily use the data. They need not go to Google and search all that, and they want to get information. Now you see how the information is coming out. JEE means 2025 on wise preparation tips. This is a very, very useful information for the students who are preparing for JEE means exam. They need not go to anywhere. Just they come to website like Edgroom and they can just explore all the information. Those are preparing for JEE means exam. Like that, we have information related to admissions, information related to exams, career option. All this is used by, we are curating this content based on the demand of the students and need of the student. For this, we are using all these ML models, make it more and more useful. And very soon, the data is going to be personalized. What does it mean? If a student is an MPC student, he'll see only information related to MPC, maths, physics, and chemistry. He's not going to see any information related to NEET exam. If he's preparing for biology at the NEET exam, he see only information related to NEET. So this is what the personalization happens. That's what Krishna said. The personalization is based on the user usage. Suppose if the user is coming to Edgroom regularly and is browsing at various places, the machine learning will understand what are the needs of the student or the needs of the teacher. We'll log it, and we're going to develop a model. Based on that, we're going to see the required data for them. And with this, a lot of information given by the teachers, we created a wonderful product called Ed Resources, where this is the information given by the teachers across India. And we have notes, handwritten notes, textbooks, authored books by some of the best teachers across India. They shared their content at Edgroom. So we're able to put it, for example, you see the physics handbook by Sunil Reddy sir, almost 2,800 people have downloaded. And so teachers are sharing content in Edgroom so that it's a community, it's a network of teachers. So it is meant for building one to other, helping each other. And even we have this filters also on the left side. You can browse the content the way you want. You can get all the previous. See, for example, you see the handwritten notes of various teachers, and some of the teachers have shared their notes. You have JEE mains papers. All lot of information is shared. So teachers can download these all information for the free of cost, and you also can share content if you have any question paper, model paper that you think that help the student community. So this is what we want to connect the teachers across India so that we can help each other, we can mentor each other, and we can also grow each other. This is the motto of Edgroom. That's why we always say Edgroom is for educating the parents, and we want to empower teachers, educate, and even we want to elevate teachers also through this activity. So I don't want to take much time. So I request all the teachers who are joined this session, please make use of the platform. And before you leave, please, I shared one Google form in the chat box. You can please fill the Google form to receive the digital certificate. Patnaik sir, I just wanted to hear from you, sir. You have seen the new website of Edgroom. How useful, in your opinion, is to the community, sir? We want to listen from you, sir.
Coming there. Just a minute. I have to unmute myself.
We can hear you, sir.
Just a moment. Yeah, I'm there. Yes, it's quite useful, especially when you have the lectures of so many other people made available for the students, something that is tested in the classroom as it is directly from experienced people, made available for other students. It's very useful as opposed to just looking at a YouTube lecture. If you have a dedicated lecture to particular topic already tested and used in a classroom. It's quite useful, and a wide range of subjects catering to everybody's needs is very good. And you put up a very good site, and you're growing it very well. I feel I would personally use definitely to enhance my classroom activity too. It is useful both for the teachers as well as the students too. Definitely.
Thank you so much, sir. And we would love to even upload your work, sir, because you also write a lot of things, and we would love to upload your content also so that the people across India can use your content. I always feel that there is one proverb I love the most, sir, from African proverb. It says that when an old man dies, a library is buried. So that struck me somewhere. So we wanted to get all the information, the most experienced teachers across India, like you, sir, because the knowledge has to be transferred to the next generation. This is one mission we started at Edgroom. So we wanted to share your content also, sir, if you can accept us.
You can definitely use my content. I have no, my content is not actually my original content. I'm teaching them very small courses. Those courses are available anywhere. If you want to, if you want anybody to listen to me, they can do it. I have not invented anything over there. Okay, it's only
Oh,
my style of doing. Other than that, you can take it. Indeed, of late, I'm teaching a graduate course online for some students over there in functions of complex variables that may also be available for people to use. You're welcome to use. You ask me whatever is available, I'll certainly pass it on. Like I've
thank you,
given the geometry
thank
notes earlier, you can take.
yes, sir.
Sure.
But next, sir, what your feedback on listener session, sir? After seeing this applications of maths in data science, what your feedback, sir?
Yeah, it's very good. I mean, uh, the way math and statistics come to use in optimizing the business strategies and reaching out more people in an effective way, even and subconsciously reaching them and uh, making them like a product is very, very interesting. Statistics and neural networks were there for a long time. For some reason or other, it took a long time before they came into. We were talking about neural networks almost 50 years ago. We heard about those things, but somehow I think the advent of very powerful algorithm at the same time computing ability of the computers have also gone up. All these things put together, many people working together seem to have now given way to very effective implementation of artificial neural networks and essentially AI.
Yes.
I'm very sure uh, there are many wide range of applications available to us in future. I think it's not going to be a long way away from here before you see machines doing a lot of the activities that we want in a very effective way. Do you know, by the way, I'll tell you, today world champion in a chess is an extraordinary person. It's very, very difficult. Somebody like Magnus Carlsen and Gukesh, they play at an extremely high level. But even they cannot play with the machine. If they have to play with the machine and win it, they have to just bring the machine down a little bit to a lower level for them to play. Machines will beat the human being black and blue. Machines have advanced so much. It's not a disgrace to human capacity. It's a celebration of the human capacity. We only have to carefully understand how we can leave our humanism in spite of the existence of all these machines who are slowly coming into our lives. In spite of all those machines around us, how the human life should celebrate its existence on the planet. That's what I would say.
Yeah. Thank you so much, sir. And unfortunately, our other speaker have stuck in another program. He couldn't join. He may just message me, and we're sorry for it. And we want to listen from the teachers who are there from the beginning of the session. Please unmute yourself and share your feedback on the session. How useful is it? And you want to ask any question to Patnaik sir, Vishwanath, they're ready to answer question. Anybody wanted to, talk? Kartikeya, you are a student. You also love maths a lot. Can you unmute yourself and share your feedback on the session? Kartikeya, can you hear me? Yeah, any teacher wanted to share your feedback on the session, today's session? Ramme garu, Ramesri ma'am,
Excuse me, sir.
Kishore garu, anybody? Yes, Kartikeya, go ahead.
Sorry, sir. Actually, I have already messaged. I was multitasking, but I heard both the speakers' things, but they were so amazing. Sir, I was a student of Ascent sir, Patnaik sir. I had never been got an opportunity to listen to you. I just kept on listening to my teachers and all from schools that you're an excellent teacher. I understood why today, and it was so great, sir. It was actually I couldn't get many of the things which you told, though I am a math student. So I got to know that I have to learn a lot. And coming to Viswanath sir, I had been listening to him. He had trained me in 2-3 sessions while I was doing internship regarding the statistical things, so I could connect to him more. And it was very nice listening to both of you, sir. And I got to know a lot of things. As I messaged already, I will definitely go through the recording once again. And I really enjoyed it, sir. And thanks to Edgroom and Venkatesh sir for organizing such a wonderful event. Like it is one of the best events actually to get this much knowledge in that such a short span of time. Uh, Thanks, sir. Thanks, Edgroom team.
Thank you, Kartika. Thank you for, yeah, definitely listening to Patnaik sir is a privilege, and working with him is a great honor for all of us. And thank you, Patnaik sir, for that. And I want to listen from other teachers. Anybody wanted to share or ask a question, because it's your responsibility for us to share feedback so that the speakers also will understand what we learned. So anybody, Rameshi ma'am, can you unmute yourself and say a few words? Kishore sir.
Yeah, thank you so much, sir. Actually, it is a very informative webinar, sir. By watching this webinar, we could remember history and now how we are using the math, like AI, history and both AI. How this is AI generation, no, sir.
Yes.
So we could remember both how we will use and how we used to be. So thank you so much, sir. And I have one question, sir.
Yes, ma'am.
Actually, what are the suggestions or ways to improve professional growth for math teachers, sir? There are many teachers are there, even they don't know how to improve or how to mm, get professional growth in especially teaching. Many of the teachers they don't know mm, uh, how to get the positions right, sir. So what are the best ways
So Patnaik sir
for
is the right person to answer the question, ma'am.
Okay.
Yes, sir.
Usually, we teach elementary classes well beyond what we have learned. If we do a MSc in the subject of mathematics, we'll be teaching undergraduate students, let's say. So there is we know a lot more than what the children know. What we have to see is that if we may be teaching a very basic course in vector algebra, but we may have done already a good course in linear algebra and abstract algebra. So you always have to keep the back of your mind about the significance of the topic that we are teaching. If we have that in mind, we know how to present something to them. You may have done a course in DSP, digital pre-signal processing. Maybe you're an engineering student with a lot of knowledge in image processing and DSP. You are teaching a vector algebra course. You know how DSP it comes out from some kind of infinite dimensional vector spaces can be used, right? So always I want as a teacher in the back of my mind the applications where they're applied clearly is there back in my mind, even if I don't tell my student. I don't think I can tell my student all the applications. I can inspire him, but I cannot really tell him all the applications. That will not be useful for him because that becomes too much to him. But when I have it in the back of my mind, I think my words will come out in a perfect way. What I am presenting will become very appealing. That is why when I see like Indian Institute of Sciences has the undergraduate program, the practitioners of the subject are teaching. So that is going to be very, very different. So if I want to be a good teacher, I should be a good learner. If I want to be a good teacher for a certain level class of students, I should have known well beyond that class. I should know the subject detailed in detail. Then the ability to present goes out. With all due apologies, I have not seen many math teachers presenting the math in a proper way. they present in a very bland way in which a bunch of equations have to be remembered and they have to be applied, they have to do some problems from them. What for? If you don't enjoy the math you're doing, what is the purpose of doing all that? You're saying that when am I going to finish this math class? So I can, a lot of people say that this semester with the math is happy. What? Ridiculous. You're not going to do anything without the math, right? And then he says, I finished my math. I'm very happy. Where are you going to go? If you're an engineer, you finish your math. What do you mean you finish your math? You will never finish your math. So math is such an important subject. The way to professionally withstand is have a in-depth knowledge of the subject. Don't underestimate the student. I'm teaching a child. Many a times he asks the question, but it's not very coherent. But he has in his back of mind something very deep he is trying to ask. I have to have the ability to see through what he's trying to ask. I'm sorry, he doesn't have enough linguistic ability or mathematical skill to present the question properly. But I can read from him. If I can read from him, I can tell him appropriately. He's also struggling. I have to understand what his struggle is. Instead of just answering a question, you also have to understand what is the process through which he has gone and help him through that. My approach to teaching in the classroom is that I don't want to prove that I know anything. I only want to prove that the students knows everything. So usually, I ask a question, student says something. I think what he says it with his own feeling and expressions, right? So I want to build up a solution from that only. That's why usually my lectures from one class to another class keep changing. It all depends on how they are talking. If they're talking about something, I will build a solution from there. I want to prove to the guy that the first idea he has in about solving a certain problem is always the right idea. So I think more than anything, you have to have the ability to recognize the the ideas behind which they're talking the students and help him grow out of that. It all comes from your well-versed knowledge. Every day I teach a little vector algebra, a little probability. When I'm teaching probability, I know my MSc course in measure theory or something completely in my hand. I get so excited on the board, but I cannot. They can see my excitement, but I will not write that excitement on the board because it will scare him off. But I'm quite excited when I say that. You know, uh, many a times I read the books in geometry. I had a lot of trouble understanding some things, but when people of high quality have written down something, when you read it, suddenly you see that the clarity comes to his picture. So your knowledge about the subject, your insights about the subject should be a lot more than what is needed just to teach that class. That should be the style of the teaching. Okay.
So it's a wonderful. I think, ma'am, you understood the essence of the target, what we
Yes,
saw, right?
yes, sir. Thank
Ma'am,
you so much.
as a personally, I felt as a teacher, definitely one wanted to grow in their profession. As I can see, two people I know them very well, Vishwanath as well as Patnaik sir. They're all the best readers, ma'am. Okay, so the
Yes, sir.
people who read a lot, as I said, as Patnaik sir said, a good teacher must be a good learner. I
Yes,
know
sir.
Patnaik sir how he read books. He always has maths books. He has that passion. Even he isn't so comfortable. He's a director of a college. He no need to update himself also. But you see,
Yes, sir.
he learns more
Yes.
than most of the teachers. So that one thing that I learned from Patnaik sir is that yes, we should be. Very humble. Even though he did his PhD from USA and he's the director of a college, but we never see such qualities in Patnaik sir. That's what made him so. I can say that successful in life because the subject that we teach, that definitely we should learn a lot by reading books. That's what he says always. And also personally feel that, ma'am, we never, if we start pleasing management, right? I personally, we never go as a teacher because, and the end product is our students. We need to please
Yes,
the
sir.
students. In the sense, pleasing the students means you start manipulation. So, we, as Patnaik sir said, they doesn't care how much you know until you make them to enjoy your subject. So, that is the one technique every teacher should understand. Make sure that your students are falling in love with the subject. That definitely a talent of the teachers. So We would love to listen from one or two teachers before we end up this program. Anyone want to share your feedback? Any teachers? Rahman sir, you're there from the beginning. You want to unmute yourself and share feedback, sir? How you felt about the session? Is it useful to you? What is that one thing that you learned? Any other teacher wanted to share?
Good evening, sir.
Yeah, sir. Go ahead, sir.
From so many days, I am observing this Edgroom, and I am also one of the. Okay, just now I got the information that we are having a meeting. So I joined lately, but so much good information I got. So if any recording is there, I want to listen from the
Yes,
starting.
sir.
So I joined nearly at 6:50 or something. First 50 minutes I don't have the information, but after listening to this, I am having very good information about the max and the teachers who give this information. So it is beyond my knowledge. Actually, I am teaching only up to 10th class, and I am teaching the foundation courses for all the 10th students, 9th students, and 8th students. But I want to know more about this. But if any video recording is there, it is better. Okay, thank you for all the members and who gave the. Okay, I am not having any words to describe. Very nice
Thank you, sir.
to participate in this program, and I am very happy by seeing this eminent persons in this meeting.
Thank you,
Thank you,
Rahman
sir.
sir. It is there, sir. It is there in YouTube. You can watch the complete, YouTube video, sir. Thank you so much for joining, sir.
Okay, ma'am.
Yeah. So anybody, one last teacher wanted to share any feedback? Otherwise, we can just wind up the show. Anybody? Praveen Garu, Praveen Vardhan, sir, you are there from the beginning. Can you share your feedback, sir?
Sir, good evening, sir.
Good evening, sir.
Actually,
Praveen Garu.
I'm in journey. That's why only I am just joining the meeting only. And
Oh.
I proudly say that I am the student of Patnaik sir in
Oh.
1997 and 99. And usually I traveled in his Chatak and I shared so many things with Patnaik sir. And
Oh.
now I am in doing research in mathematics now. I always feel that Patnaik sir is my role model. And of course, late I have started my PhD, but even I'm taking Patnaik sir is my model. And I'm having very good experience with Patnaik sir. But I'm in bus actually. I'm in traveling. That's why only I'm not sharing anything. Okay, sir.
Oh.
But it's a very good, very. I feel very happy to see again Patnaik sir class once again after a long time, sir. Thank you very much, Patnaik sir, and Venkatesh sir. Thank you very much giving me this opportunity. Thank you very much, sir.
Yes, sir. So wonderful surprise, Patnaik sir, on the mathematics day. So
Good. He's doing PhD in mathematics. I would like to talk to you later on, so you can share some of your experiences. Sure, definitely.
thank you, Praveen Gar, for sharing your feedback, even though you're on travel. Yes.
Thank
So anyone wanted to share one last feedback as we close the session, because Patnaik sir is there. Thank you so much, sir. You are there from 6 o'clock. And once again, we want to thank all the teachers who are watching live in YouTube and who joined. Very good number of teachers have joined the session in June, and it is very great pleasure for all of us. We thank Patnaik sir for accepting. It is planned from so many days. It happened on a right day. I was asking Patnaik sir for many days to give this lecture, and ultimately everything has a reason. So it happened on a very interesting day. Thank you so much, sir, for joining and staying till the end of the session and sharing a lot of your insights, for inspiring the teachers to be the best in maths. And we thank Vishnath for sharing his wonderful experience as a data scientist. And that shows your maturity in data science. As you said, you are the first generation of data scientist. That's wonderful. We learned a lot the importance of mathematics. And we also thank Srinivas Sakalla. He couldn't join the session because of from unseen what called as commitments. We all thank all the teachers who shared the feedback and who joined on this wonderful day, spending a lot of your time on this Sunday. We'll want to see you in another session very soon. Thank you so much. Please keep using Edgroom and let us all connect together. Let us all grow together. Let us all build together. Thank you so much for all of your time and efforts. Thank you, Patnaik sir, once again.
Thank you very much. Thank
It's
you.
a great pleasure to have you, sir. Thank you so much, sir. Yes. Yeah, this is all from my side. We are going to wind up the session. I hope you all have filled this Google form. Dear teachers, please fill the form. We are going to send you the certificates very soon. Thank you so much.